Welcome to this comprehensive guide on how to prepare, write, and publish a research paper. This is one of the most important skills in science and academia. Before we dive into the how, let's ask, why do we write research papers in the first place? Science advances through shared knowledge. When you publish your findings, you contribute to the global body of human understanding. Research papers preserve discoveries for future generations. What you write today might solve a problem decades from now. Publication establishes priority and credit. It's how the scientific community recognizes who discovered what first. Think of writing a research paper like planning a road trip. You need a destination, a map, and interesting stops along the way. Your research question is the starting point. Your methods and data are the journey. The published paper is your destination. Let's break down the entire process into phases. Phase 1 is preparation. Before you even start writing. Step 1. Define a crystal clear research question. This is your foundation. Without it, your paper will lack focus. A good research question must be specific enough to test, important enough to matter, and feasible with your resources. Here's a bad question. Why is climate important? This is too vague and broad. Here's a good question. How does carbon dioxide concentration affect ocean pH? This is specific, testable, and scientifically important. Step 2. Conduct a thorough literature review. You need to know what's already been discovered. A typical graduate student might read 50 to 100 papers before starting their own research. This builds your knowledge base. As you read, identify the gaps. Where does existing knowledge end? That's where your contribution begins. Step 3. Design a rigorous methodology. This is the heart of your research. The golden rule. Your methods must be reproducible. Another scientist should be able to follow your procedure exactly and get similar results. Consider sample size carefully. Let me show you why this matters with a key equation. The standard error equals sigma divided by square root of n. Here sigma is the population standard deviation and n is your sample size. This equation tells you how precisely you can estimate the population mean from your sample. Let's say the standard deviation is 10 and you have 4 samples. The standard error is 10 divided by square root of 4, which equals 5. But if you increase your sample size to 100, the standard error drops to 10 divided by 10, which is just 1. Much more precise. Notice that to cut uncertainty in half, you need to quadruple your sample size. This is why large studies are so expensive. Now we move to phase 2, writing your first draft. This is where many researchers struggle. Research papers follow a standard structure. This isn't arbitrary. It's evolved over centuries to communicate science effectively. The standard sections are abstract, introduction, methods, results, discussion, and conclusion. Each serves a specific purpose. Here's a professional tip. Don't start with the introduction. Start with the methods section. The methods section is easiest to write because you already did the work. You're just documenting what you did. Then write results, then discussion, then introduction, and finally, the abstract. This order makes logical sense. Let's dive deeper into each section, starting with methods. Be specific enough that someone could replicate your work exactly. Include equipment models, software versions, and parameter settings. List all materials and equipment. For example, we used a Zeiss Axio-Observer microscope with a 63x oil immersion objective. Always specify your statistical tests. For instance, we performed a two-tailed t-test with alpha equals 0.05. The threshold p less than 0.05 is the standard criterion for statistical significance in most fields. This means there's less than a 5% probability that your result occurred by random chance alone. Now let's talk about the results section. This is where you present your findings objectively. Present your data without interpretation. Save the interpretation for the discussion section. Use figures and tables to present data visually. A well-designed figure is worth 1,000 words. Always state whether differences are statistically significant. For example, Group A showed significantly higher values than Group B, with p equals 0.02. Here's an example of a good result statement. The mean reaction time was 23.4 milliseconds with standard deviation of 3.1 milliseconds based on 50 trials. Include clear graphs with labeled axes, error bars, and legends. Make sure every element is readable. The discussion section is where you interpret your results and place them in context. Start by briefly summarizing your main findings. Then interpret what they mean. Compare your results to previous studies. Do they agree or disagree? If they disagree, why might that be? Discuss limitations honestly. Every study has limitations. Acknowledging them shows scientific maturity. Suggest future research directions. What questions does your work raise? What should be studied next? Think of the discussion section as a conversation with other scientists in your field. You're saying, here's what I found, here's what I think it means, and here's how it fits with what others have found. Now let's talk about the introduction. This sets up your entire paper. Use the funnel strategy. Start broad, then narrow down to your specific question. Start with the general importance of your field, narrow to your specific topic, and end with your exact research question. Paragraph 1 establishes broad context. Why should anyone care about this topic? What's at stake? Paragraphs 2 and 3 provide specific background. What do we already know? What gaps exist? The final paragraph states your study objective clearly. In this study, we aim to determine how X affects Y. Finally, write the abstract last. This is a complete mini version of your paper. Most journals require abstracts between 150 and 250 words. Every word must count. Include 1 or 2 sentences each for background, methods, key results, and main conclusion. The abstract is crucial because it's often the only part people read. Make it compelling and clear. Phase 3 is revision. Your first draft is never your final draft. Here's a critical tip. After finishing your first draft, let it sit for at least 1 week. Don't touch it. When you return with fresh eyes, you'll catch errors and awkward phrasing you were blind to before. Read your paper aloud. If you stumble over a sentence while reading, your readers will stumble too. Rewrite it. Check every number, every reference, every citation. Errors here damage your credibility. Get feedback from colleagues before submitting. They'll spot issues you missed and suggest improvements. Let me share some common pitfalls that trip up researchers. Pitfall 1. Overselling your results. Be confident, but not overconfident. Avoid words like proves or demonstrates unless you truly have ironclad evidence. Better words are suggests, indicates, or supports. These show appropriate scientific caution. Pitfall 2. Ignoring negative results. If you tested something and it didn't work, that's valuable information. Report it. Pitfall 3. Excessive jargon. Write clearly. If a simpler word works, use it. You're trying to communicate, not impress. Pitfall 4. Weak statistical analysis. Make sure you're using appropriate tests for your data type. Now let's talk about the publication process. This is where your paper meets the world. Step 1. Choose the right journal. Consider the journal's scope, impact factor, and audience. The impact factor is a metric that measures how often papers in that journal are cited. Higher impact means more prestige. Impact factor equals citations in a given year divided by papers published in the previous 2 years. Top journals like Nature, Science, and Cell have impact factors above 40, but they're extremely competitive. For most researchers, strong field-specific journals are better targets. They're still prestigious, but more accessible. Step 2. Prepare all submission materials. This includes more than just your manuscript. You'll need a cover letter that briefly explains why your work is important and suitable for that journal. Many journals ask you to suggest potential reviewers. These should be experts in your field who don't have conflicts of interest. Prepare all figures in high resolution. Most journals want at least 300 dpi for print quality. Step 3 is peer review. This is the quality control mechanism of science. After submission, the editor does an initial review. If suitable, your paper goes to peer reviewers who evaluate it critically. Peer review typically takes 2 to 6 months, sometimes longer. Patience is required. Reviewers assess 3 main things. Is the work scientifically valid? Is it significant enough? Is it clearly written? You'll receive one of several possible decisions from the editor. Outright acceptance is rare on first submission. Most papers need at least minor revisions. Minor revisions means the reviewers found issues but think they're fixable. Address every comment thoroughly. Major revisions means substantial changes are needed. This might require new experiments or analyses. Rejection happens. Don't take it personally. About 70% of papers are rejected from their first submission journal. When you get reviewer comments, respond carefully and professionally. Address every single comment, even if you disagree. Explain your reasoning clearly. Always thank reviewers for their time. Remember, they're volunteering their expertise to improve your work. Provide a point-by-point response document. Quote each reviewer comment, then explain how you addressed it. Highlight or mark all changes in your revised manuscript so reviewers can easily see what you modified. Let's talk about realistic timelines. How long does the entire process take? The research itself can take anywhere from 6 months to several years, depending on your field and project complexity. Writing your first draft typically takes 2 to 4 weeks of full-time work. Part-time, it could be several months. Revision and getting co-author feedback adds another 2 to 4 weeks. From submission to first decision averages 2 to 6 months. Then you need another 2 to 4 weeks to revise and resubmit. After acceptance, final publication takes 1 to 3 months for typesetting and production. Total time from starting research to seeing your paper in print is typically 1 to 2 years, sometimes longer. Let me highlight some key equations that every researcher should understand. Statistical power equals 1 minus beta, where beta is the probability of a type 2 error or false negative. A power of 0.8 means you have an 80% chance of detecting a real effect if it exists. This is the standard target. To calculate required sample size, n equals 2 times the quantity z alpha plus z beta squared times sigma squared, all divided by delta squared. This equation tells you how many subjects you need to detect a difference of size delta with specified power and significance level. Effect size equals the difference in means divided by the standard deviation. This standardizes how big your effect is. Cohen's d-values of 0.2 are considered small effects, 0.5 medium, and 0.8 large effects. Now let me share some advanced tips that separate good papers from great ones. Use active voice when possible. We measured the temperature as clearer than the temperature was measured. Make your figure self-contained. A reader should understand a figure just from its caption without reading the main text. Use consistent terminology. If you call something a sample in the introduction, don't switch to calling it a specimen later. Number your hypotheses and predictions. This makes it easy to refer back to them in the results and discussion. Always report effect sizes along with p-values. Statistical significance doesn't tell you how big or important an effect is. We must discuss the ethics of publishing. This is critically important. Never fabricate or falsify data. This is scientific fraud and can end your career permanently. Always cite previous work appropriately. Plagiarism includes taking ideas without citation, not just copying words. Disclose any conflicts of interest. If a company funded your research, readers need to know. Include all contributors who made substantial intellectual contributions as authors. Authorship matters for careers. Share your data and materials when possible. Open science benefits everyone and increases your paper's impact. Let's talk about dealing with rejection, because it will happen to everyone. First, understand that rejection is completely normal. Even Nobel laureates have papers rejected regularly. Learn from reviewer comments even if the paper was rejected. They often contain valuable insights that will improve your work. Revise your paper based on feedback and submit to another appropriate journal. Persistence pays off. Some of the most highly cited papers in history were initially rejected. The famous Krebs cycle paper was rejected by Nature. Let's discuss open access publishing, which is increasingly important. Open access means anyone can read your paper for free without a subscription. This dramatically increases your potential audience. The author or their institution typically pays a publication fee ranging from $1,000 to $5,000. Studies show open access papers get cited more often because more people can read them. Many funders and institutions now require open access publication. check their policies before submitting. After your paper is published, you can track its impact. Citation count shows how many times other papers reference your work. This is a key metric of scientific impact. The H-index is a measure of both productivity and impact. An H-index of 10 means you have 10 papers with at least 10 citations each. Altmetrics track broader impact, including social media mentions, news coverage, and policy citations. Remember that impact takes time. Some papers don't get widely cited until years after publication. Let me end by returning to the fundamental question, why does all this matter? Research papers are the primary mechanism by which human knowledge grows and spreads. Your work builds on thousands of papers that came before, and it will enable discoveries by researchers who come after. Every major scientific breakthrough, from DNA structure to the Higgs boson, started with someone writing a paper. When you publish research, you're contributing to humanity's collective understanding of the universe. That's profound. Let me summarize the complete process from start to finish. First, define a clear research question and thoroughly review existing literature. Design rigorous methods with adequate statistical power and sample size. Collect and analyze your data carefully, using appropriate statistical tests. Write your paper in this order: methods, results, discussion, introduction, and finally, abstract. Revise extensively after letting it sit. Get feedback from colleagues. Choose an appropriate journal, and prepare all submission materials carefully. Respond professionally and thoroughly to peer review comments. Persist through the revision process, and don't be discouraged by rejection. When your paper is published, celebrate this achievement and track its impact over time. Writing and publishing research papers is challenging but deeply rewarding. It requires scientific rigor, persistence through setbacks, and the ability to communicate complex ideas clearly. Remember that every expert was once a beginner. Your first paper won't be perfect, but each one you write will be better. The process gets easier with practice. By your 10th paper, you'll wonder why the first seemed so hard. Most importantly, your contribution matters. Science advances one paper at a time, and yours is part of that grand tradition.